Today I'm going to teach you everything you need to know about lightning and how to be protected when it strikes. Lightning is a natural phenomenon consisting of electrostatic discharges occurring through the atmosphere between two electrically charged regions. One or both regions are within the atmosphere, with the second region sometimes occurring on the ground. Every second, there is approximately 100 lightning strikes occurring throughout the world. Each year in the United States, lightning kills around 44 people and injures hundreds of others. A typical lightning bolt contains enough energy to light a 100-watt light bulb for over 3 months. In a cumulonimbus cloud, huge amounts of static electricity form, perhaps because of friction between ice crystals and hail. Some of this electricity has a negative charge and collects near the base of the cloud, creating a strong negatively charged region. As a cumulonimbus cloud moves over an area, a positive charge develops on the ground beneath it. Because opposite charges attract, the large negative charge in the cloud is strongly attracted to the large positive charge on the ground. However, the air keeps the two charges from each other. Eventually, the attraction between the charges becomes so strong that it begins to overcome the air's ability to keep the charges apart. From the cloud, a stream of electrons begins to move jerkily toward the ground in a series of steps about 50 millionths of a second apart. Each step covers a distance of 2,100 meters. This electron stream, called the stepped leader, is barely visible but less time than it takes to blink an eye. The stepped leader has come within 100 meters of the ground. The positive charge on the ground, attracted by the approaching stepped leader, launches upward in a positive streamer that rises to meet the stepped leader. The positive streamer that rises to meet the stepped leader. The positive streamer usually originates from the immediate area's tallest object, which typically has the greatest positive charge. When the positive streamer and stepped leader meet about 30 m above the ground, a huge current of positive charge surges upward from the ground to the cloud. The upward flow of positive charge, called the return stroke, forms the brilliant flash of light that can be seen. The return stroke of a typical lightning bolt is only 1 cm wide and lasts only a few millionths of a second, but the power flowing through it typically reaches about 2 trillion watts. The tremendous rush of charged particles heats the air in the return stroke to over 30,000 Celsius, which is about 5 times the temperature of the sun. The air's intense heat gives the return stroke its white appearance, although the return stroke may appear another color due to various particles in the air between the observer and the return stroke. The cumulonimbus cloud usually carries such a huge electrical charge that a second leader, called dart leader, travels down the channel of the first strike. The dart leader, which travels much faster than the stepped leader and does not move jerkily, initiates a second return stroke. As many as 20 dart leader to return stroke combinations may occur in less than a second, giving the appearance of a single flickering bolt. The heat from the return stroke causes the air near the lightning bolt to expand explosively, forming a shock wave of sound known as thunder. Typically, thunder can be heard up to 16 kilometers away from where the lightning occurred. Because light travels faster than sound, a lightning flash is seen before its thunder can be heard. The lightning bolt to expand explosively, forming a shock wave of sound known as thunder. Typically, thunder can be heard up to 16 kilometers away from where the lightning occurred. Because light travels faster than sound, a lightning flash is seen before its thunder can be heard. The type of lightning we have already described is called negative cloud-to-ground lightning, because the stepped leader travels from a negative region of the cloud down to the ground. Positive cloud-to-ground lightning occurs from the cloud to the ground, and another from the ground upwards to the cloud itself. Negative cloud-to-ground lightning is much more common, and it often results in the bend or fork that we're all familiar with in photos. On the other hand, ground-to-cloud lightning occurs in a single, much more powerful bolt. Heat lightning occurs far away enough that it cannot be heard. It's called heat lightning due to the fact that it often results in a reddish tint to its strike. It also often occurs in the summer months. Cloud-to-ground. There are 2 types of cloud-to-ground lightning, one that occurs from the cloud to the ground, and another from the ground upwards to the cloud itself. Negative cloud-to-ground lightning is much more common, and it often results in the bend or fork that we're all familiar with in photos. On the other hand, ground-to-cloud lightning occurs in a single, much more powerful bolt. Cloud-to-cloud. Cloud-to-cloud lightning occurs between 2 or more clouds. This tends to result in a very long bolt between the clouds themselves, sometimes referred to as horizontal lightning. These bolts can travel for hundreds of miles between clouds, but they don't pose much of a risk to humans, as they don't reach the ground. This may also result in spider lightning on the underside of the clouds. Sheet lightning. Sheet lightning, also known as intra-cloud lightning, is the most common type of lightning. It happens entirely inside the cloud itself, meaning that this type doesn't even strike the ground. It creates a sheet of light in the sky, hence its name. And it occurs as the current of electrical charges connects within the thunderstorm cloud, causing it to light up. Cloud to air. Cloud to air lightning strikes occur when the current within a cloud strikes the charged air around it. While not quite the same as an intra-cloud lightning strike, this flash lightning won't reach the ground. Anvil lightning. Anvil lightning occurs at much slower speeds than other types, resulting in humans being able to see and perceive them in the moment much easier. These bolts occur on the top part of the cloud and then travel down to strike the ground, meaning they potentially can be very dangerous. Lightning is one of the most deadly weather phenomena. It can strike and kill at any time without warning. These are some simple steps that you can take to protect yourself. If a storm is close enough that you can hear thunder, go to a safe place and stay there until it has been no thunder for at least 30 minutes. If you see that a storm is developing, go to a safe location right away, even if it's no thunder yet. When choosing a safe location, look for a closed building with plumbing and electricity. Examples are houses, schools, and most businesses. Structures that have large openings to the outside or do not have plumbing and electricity are unsafe, like porches, patios, and picnic shelters. If you cannot get to a safe building, most closed vehicles are also safe. Avoid convertibles, which is unsafe even if the top is up, and open vehicles like golf carts. Once you're inside, avoid windows and doors. If lightning strikes the building, it would probably travel through the plumbing, electrical, or telephone system, so avoid plumbing fixtures, electrical devices, and corded phones. Cordless phones and cellular phones are safe if they are not connected to a charger, since lightning can damage sensitive electronic devices like computers and televisions even. If it does not strike them directly, you may want to unplug them before lightning starts. If you are outside when lightning starts, you should seek shelter. Immediately, it is unsafe to be outside during a thunderstorm. If you cannot get inside, you can slightly reduce your chances of being struck by finding a low spot away from water, trees, open fields, and metal objects. Do not lay down. Lying down increases your chances of being hit by currents traveling through the ground if lightning strikes nearby. A common myth is that wear rubber-soled shoes will protect against lightning strikes. However, rubber soles actually offer no lightning protection.
If you found this video helpful or interesting, please like and subscribe for more content like this.